Okay, I've gone through and I've removed the button from my circuit here because the next thing that we're going to take a look at is an analog input. With the button, we were limited to just on and off. So if I look at my code, if button value is high, do this. I could have also said if button value is low, do something else. An analog input allows us to do a range. So we could say if button value equals 10, do this. If it is 20, do this. And you can go from 1 to 1023. Now the little digisparks that we're using won't be able to do that whole range, but we can call around 10 programs with it. So we're going to be using analog reading instead of a button. To do that, we need an electronic component that is capable of analog. So I'm going to go back to components and find something called a potentiometer. But we do have other analog components we can use though. I've got these two 10K potentiometers. They're also known as trim pots, these ones. You could use them if you wanted. We've also got things down a little lower here. Things like photoresistors. So this is an analog sensor that measures the amount of light that you have, and then it can adjust a circuit to go with the light. But we want, right at the very bottom, this potentiometer here. Just visually, it's a little easier to use. So I'm going to grab this potentiometer and put it in my program. Get rid of the components there. Now, with my potentiometer, I've got 3 legs. One leg needs to be tied to 5 volts, and I'm going to make that red. The outside leg needs to be tied to ground, and I'm going to make that one black. And the center line leg needs to go to an analog input. Play with my curvy lines again here. And we'll just put that in A0 for now. And I'll change the color to purple just so it's different than our green ones there. So I've got my purple line going back. So I've got my potentiometer. Now the thing with the potentiometer, didn't want to move that. The thing with the potentiometer is you can move this around and it'll give you different values. So say this is 0, this will be 1023. And you can have statements that go around the potentiometer. Now we've plugged into A0. So if I go back to my code, up in my scope I had my button and my button value. I'm going to change this now to my pot equals A0 and my pot, I'm going to make this lowercase, just make that easier. Pot value equals 0. So same idea as the button, but now when the potentiometer starts, its value is 0, and it's plugged in A0, it's not plugged in the digital port where it was before. Because it's plugged in an analog port, I don't need a pin mode for it, so I can just delete that. And come down here. So if we want pot value is going to be analog read pot. So same idea as the button, just this time we're using an analog read instead of a digital read. And we're using pot value equals pot. So it's going to take the value of pot and assign it to pot value. Now, because we're using analog, it's not going to be just high and low anymore. So let's say if, actually let's try something a little simpler here. I'm going to drop that if statement altogether. I'm going to drop that else statement. So I've just got my bike light 1000. I'm going to assign the value of pot value to my delay time so you can just see what's happening a bit better. Move that bracket up a bit, just clean up our code. So we've only got 2 lines. Upload and run, we'll see if I made any mistakes. And I turn this on, so I've got my flashing. as I move this, you can see that it's flashing faster. So this is my 0 location. As I move around, it slows right down, and then this would be my 1000 location. So you can see how that is affecting that variable. So back to the code editor, all it's doing here is taking the pot value and assigning it to A time. So now I can have it between 0 and 123. And you could play around with this too. You could say pot value, oops, stop simulation. You could say pot value times 3 to give you a larger range. So now here, this is going to be 3 seconds. So that's 1 times 3 is pretty small. And as you go back, that multiplication just gives you a bigger range on what this is going to do. Now this might be enough for your program depending on what you've decided you're going to be building. But let's dig a little deeper into it. So let's get rid of that bike light's pot value and just turn it back to whatever we had it before. Say 500, doesn't matter. And we're going to play with some if statements. So let's say if pot value is greater than or equal to 200, then bike light. So if the pot value is greater than or equal to 200, bike light turns on at 500. And I could say here else we'll go bike light again. $2,000. Another bracket to close that else off. Upload and run, and we can see what's going to happen. So this should be the over 200, and there we go. So we're less than 200. There's the time difference, so nice and slow. Over 200, we should be fast again. Now we're not limited to just the if and else, so I can have more than here. So okay, if let's say if it is, stop simulation. Let's play around with this. I'm going to delete this. If pot value is less than or equal to 200, I'm going to add another void here. So let's say void turn off. I'm going to give it an A time. Doesn't really need it, but that's okay. And I'm going to cut and paste all these. So void turn off is just going to turn off the LEDs. So if pot value is less than or equal to 200, turn off. What that'll do, as long as it's less than 200, it's going to stay turned off. So it's like an off position on our potentiometer. Now I can start playing around a bit more. So let's say if pot value is greater than or equal to 201, and forgot my bracket there. So if pot value is greater than or equal to 201 and pot value is less than or equal to, let's say 500 for now, add a bracket. Now I can turn on my bike light. And I'll set that to 500. So if it's between the two values, it's going to be bike light on at 500. Close that off with a bracket. And now I can also say, let's say if pot value is greater than or equal to 501, then we can do another line of code. So in this one, let's say I had that all on code, so let's say all on, and we'll set that one to 300. Not that these times matter because I am just playing right now. Close off the bracket. So if it's less than 200, it's off. If it's between 200 and 500, the bike light turns on. And if it's greater than 501, all on turns on. So we'll upload and run. Apparently I've made a mistake. So turn off. Where did I make my mistake and turn off? I forgot to add integer. We'll add that back in. Upload and run. That should fix it. There we go. Back to my circuit. So greater than 500, there's my all on. Between 200 and 500, there's my bike light. And down here, less than 200, it turns the circuit off. So you can see how that program has now been indexed into this potentiometer. What I want you to do now is go through and make a new if statement for each one of your functions. So at different positions on your potentiometer, it can call the different functions. And it's pretty easy again, just cut and paste. So control copy, change your values. So let's say this is, now let's change this one up here to 300. This can be 301 to 4. And play with it till you get them all to work in the functions. And make sure you share that with me. Alright, that's the end of that video.